He's here to participate in a show that's premiered last night privately and tonight publicly at UC Irvine to bring in the new Beale Media Arts and Technology Center. The show is called Shift Control, and it deals with artists who are interested in using gaming metaphors and technologies to create interactive works. In fact, our faculty, Rebecca Allen, is part of the show, and most of you will be trekking down there right after this talk. So you'll be seeing Gordon there, and just a brief introduction. He's a computer programmer who has developed software for flight simulations, film effects, PC computer games, and now he's doing something on the internet. He has collaborated on a piece that I'm sure he'll talk about called Technosphere that involved a group of people and involves AI on the net, creating creatures and developing them online. He's currently the course director for the MA in the Interactive Multimedia at the London College of Printing, supporting research in digital media at the MA and PhD levels. Please help me introduce and welcome Gordon Selley.
Thank you. Hello. Thank you very much. That nice introduction. As mentioned, I'm here today primarily to talk about Technosphere, which is now quite an old project in internet terms. It's over 5 years old, and I'll be giving you more details about the history. And what I wanted to talk to you today particularly is about our experiences as a team of collaborators in building Technosphere and the kinds of things that we've learned from the process of sort of moving from more traditional media and gaming to the internet. It's a slight change in my title. I've now left the London College of Printing, so I'm just about to emigrate to the US, but I'm now an Associate Research Fellow with the London College of Printing to maintain links with their PhD and grad programs. So a quick introduction to Technosphere. It's a website which allows people to have access to a 3D online world, create artificial life forms, put those life forms into the world, track those creatures as they grow and evolve and have families and experiences in that world. And the creatures actually send back emails to the people who created them. So fairly simple by sort of contemporary modes of interaction. But we've learned quite some interesting things about the way people engage with the internet as a medium. Just a little bit of background to some artificial life. I'm sure a lot of you here are familiar with the concepts of artificial life. But I thought I'd cover it for some of the people who aren't so familiar. Really, artificial life allows us to study models for biological life, investigate the way in which we work and other creatures and life forms on the planet work, provide models for other forms of life, computer-based life. There's some particularly interesting work being done in this area. It's kind of characterized in its approach in that it's non-analytical. It's not really based on dissection and going finer and finer into detail, but really bringing ideas from many disparate subjects together, from philosophy, from art, from science, from biology, and synthesizing those into really what is a new sort of collaborative effort in this area. So it's really a synthetic approach to building this development we call artificial life. Typically, artificial life looks at the small and the large, anything from looking at a whole organism or a whole ecosystem with many organisms down to your protein or cellular level. So as you can imagine, that covers a tremendous amount of areas to study, interactions between creatures, interactions within creatures themselves. And I guess the term was really first invented and used by Chris Langton back in 1987. Sorry, having problems hearing me?
Yeah. I'm not sure that feedback comes from. Maybe you just speak up.
How's that? Yeah? Is that better? Okay. Okay, can you hear me now? All right. So moving on to which areas of people are interested in A life right now. Obviously, biologists are interested in artificial life, looking at the body, looking at the way plants grow, plants evolve. Obviously, we've got programmers working in the A life area, developing algorithms, testing ideas, everything from genetic algorithms to sort of neural networks and artificial intelligence. Philosophers long been involved in trying to decide what life is and how it might work. They're involved in artificial life. Obviously, the medical industry, studying the spread of diseases and viruses through the body and through populations. Anthropologists studying how mass movements of creatures and humans across the globe have affected populations and how specific creatures have lived and died in masses. And more recently, artists and designers developing artworks using artificial life. So as you can see, a tremendous range of interest in artificial life. So really, the main aim is to really understand aspects of life, to investigate it, to enhance our potential. There's a lot of interesting work in applying artificial life to solutions, everything from switching to telecommunication switches using insect theories of how insects navigate their own information systems. And I suppose really what I find most interesting is to create and make new forms and experiences, in this case, art. So Technosphere really approaches artificial life on the grand scale. We're looking to simulate a whole artificial nature, obviously with its wonderful mix of randomness and order, which I'm sure some of you are familiar with fractal growth. We use a lot of fractal work in Technosphere, both in generating terrains and plants and living organisms within Technosphere, and I'll talk a little bit about these later. We're interested in modeling the whole ecosystem, not just a single life form. Tremendous amount of A-life is done in simulating one cell or interactions between groups of cells or one or two organisms. We have thousands, hundreds of thousands, millions of creatures interacting. And we're very interested in the relationship between the creatures and the environment. Life really can't be considered separate from the environment. The terrains we live in, the atmosphere, the weather systems we're in, all have an effect on us. And only when you connect artificial life to some form of environment can you really start to study the relationship between the two. Technosphere allows for a type of evolution. It's not a free-form evolution. Obviously, we're constrained by our own programming capabilities and approaches, but enough to test some concepts of Darwinian evolution. And perhaps the most primary aim is that we wanted to make Technosphere easy to use. I think for a long time, artificial life, although being very, very interesting, really didn't get a lot of access from the general public. If you've ever read your way through some of the Santa Fe Institute papers, you'll realize it's pretty impenetrable stuff to the general public. So really we wanted a very, very simple access facility to these kind of ideas. So Technosphere really has come about by a series of collaborations with teams of people that have come and go over the years, for 5 or 6 years now, but they include people who've worked in installation artwork, virtual environments. We had a PhD researcher from Edinburgh University working with us, 3D simulations, artificial life, obviously developers in the World Wide Web, CGIs, database, front ends, back ends, all of those things. And we have people who've worked in the animation industry, building components and environments for us. I think this has been one of the most wonderful things about working on Technosphere, is having these sort of mixed collaborative teams of people working together. Currently, it's a collaboration between Jane Profit, who's a media artist, originally a video artist, now working in digital media. Mark Hurry, who's a real-time 3D graphics programmer involved in early computer graphic work in the UK, and myself, who sort of straddles several main areas from computer graphics, A-life programming, and design. Originally, I was a graphic designer who went off to study programming for graphics and ended up working in the flight simulation industry. So I kind of transgressed both of those areas. A little bit of history to Technosphere. Some of the first ideas we had for Technosphere started in 1992, where we wanted to have the experience of placing the visitor to a gallery in a virtual environment. I suppose what later became known as the cave environment. Now clearly back in 1992, with the resources that we had, this was not going to be possible. And so we had the idea of using an agent to enter a 3D world and to report back on the experiences of that agent in the world, to send back images, experiences that that agent had had in the world. Simply because we couldn't put the gallery visitor into that world in the way that we wanted to. So in '93, we started to design some landscapes and environments that we thought might be interesting to have experiences in, and approached the Arts Council of Great Britain for some basic funding to get this project up and running. And they gave us a small grant, which we bought a small computer to start what we thought would be a 2-week project. We'd go online for 2 weeks as a piece of work, and then close it down after 2 weeks. And here we are sort of 5 years later with it still running. So we went live in 1995 with a very, very small web server that allowed people to make creatures. And in 1996 we developed a much more sophisticated machine that could monitor the whole ecosystem, send out emails, and do all of the hard work that we used to do by hand in the first version. Since then, we've won several sort of prizes in the sort of digital media arts world, Pre-Ars Electronica perhaps being the most well-known. 98, we were involved in the Imaginaria in the ICA in London. And in 1999, we won a commission to develop a 3D real-time version of Technosphere from the National Museum of Film, Photography and Television in Bradford. And here we are in the year 2000, we've just released Technosphere 3 and 4, and that is a new website and a new real-time 3D version. And we have plans over the next year to link those two together. These are some of the people who've worked on the various versions. I'll just skip through there. And as you can see, the teams are quite large, and it's quite an achievement, I think, to get these kind of teams together when you have no budget. Sure.
There you go.
Okay.
Thank you.
Is that better? You can't hear me, can you? How's that? Yeah? It's probably a good thing. Okay, this is the team that we had last year. Using the funding we got from the Bradford Museum, we were able to put this team together. Now that team is disbanded, but we're all still sort of working together in an informal way. I should say that Technosphere has really been put together in spare time. We're not a company. We don't make money from it. It's no good, is it?
Maybe I got this on mute.
Okay. Oh, no. Do you want to stop for a while and work this out? No? Okay. Go ahead. All right. Okay, so what I want to do is just demo the web version. This is actually running from this PC here. So we won't actually be sending and receiving the email, but I'll just give you an overview of the website, let you see how it works. I think the most interesting thing is that you can quite easily get into building creatures simply by selecting these components. You've got a choice of heads, bodies, different wheels, and eyes. Now what we're doing when we select these components, as well as making an aesthetic choice, we might like some of these shapes, we're actually selecting a whole range of parameters that describe how the creature will function. When we're selecting the heads, we're really selecting things, parameters like how much food that head can bite in one go, how strong the jaw might be, how much energy that head might take to use. And similarly in the bodies, where we're selecting things like how structurally sound the body might be, how strong it is, how much food it can actually hold, what the digestion rates are, and again, how much energy that component uses. And similarly for the wheels, they have different speeds, different sizes that allow them to do different things. And the eyes have different focal fields, different viewing angles and viewing distances. And so from this small selection of parts, you can make quite complicated and differently behaving creatures. Now, after you've created your creature, you get to name it. This turns out to be quite an important feature in the attraction of Technosphere. You enter your email address and a password. You choose a password for your creature. Now, when you click on Submit, the creature actually gets entered into the world, and you get sent a confirmation email saying your creature's entered the world, and with all of the information about your creature. And then, over a period of time, your creature will interact with other creatures in the world and start sending you email messages back. So what we can do is we can actually use some of the tools to find out about creatures in the world, using the ID number of each creature. And here we get a brief summary of where that creature is right now. Here we can see the time at which the creature was born, the time at which it died. There's a slight discrepancy here, as this is a version that I'm just developing right now. And a summary of all the sort of key features on the right-hand side. What I'm going to do is just go straight to the top creatures. Now, these are the current creatures in Technosphere that are the biggest and the best. Obviously, we've got the fastest creature with an indication of how fast that creature is. The biggest, size in meters, the oldest, the most deadliest, and the most adventurous, and the creature with the most children. And what we've done is we've built in some functions to allow you to see the family trees of these creatures. So you can see the family tree for this creature here. You can see the two parents and the offspring on the right-hand side. And if you look closely, you'll see that the body components of the offspring slightly vary from that of the parent. And this is to do with the evolution and the crossover of parameters that we're using to simulate evolution. And what we can do is we can go deeper down the family tree by clicking on these hyperlinks. So after a period of time, you get this huge web of family trees that all interlink and allow you to sort of study the flow of parameters down through the generations in Technosphere. We have the world statistics, which is basically a list of all the creatures that have lived, number that have died, and we're constantly expanding this functionality here. And perhaps I should have mentioned earlier, we have carnivores and herbivores. Now, it's the job of the carnivores to chase the herbivores, catch them if they can, overcome them, and use them as food. And there's a sort of constant shift of sort of dominance between the herbivores and the carnivore populations in Technosphere, which I'll talk about in a bit. So that's a quick overview of the use of the system.
What you do with the online version, basically you create a creature, and then it goes into a world. It's not like you're watching it move fast, or you're watching it.
Absolutely, yeah. This is not this is essentially a text-based, information-based experience at this point.
So the program's kind of clunking along, and you just look to see what the statistics are, but not to actually watch it doing any of this.
Absolutely, yeah. That's something that we're moving on to right now, but this is the original sort of version of Technosphere, which is the web version. And this is a typical email that you might receive from a creature in Technosphere, telling you a summary of the events that creature has gone through during that day. So you can see it's a sort of what I call a weak narrative. There's some key highlights in there that you can really embellish with your own imagination You can quite often people get quite involved in their creature, assigning them all kinds of characteristics, and they email us and tell us stories about their creature and why these events took place. It's quite interesting how such a small amount of stimulus, really, text-based stimulus, can really get people engaging with their creatures. Okay, so let's have a look inside. This is one of the first animations that we did back in '94, and this is what we thought Technosphere might look like. We thought it might be this environment with a large sluggish creature moving through. Tim, I can't get any sound out on the computer. Thanks. Yeah, so that's how we originally envisaged Technosphere. We always thought that it would have sound in there and that the creatures would use sound to communicate over distances. And this is what we thought the creature might look like. And it was a long time, really, before we could run a simulation and get a snapshot of what was going on inside. We were using very basic PCs, early sort of P90s and things to develop this. And these are some of the first shots that we got out when we actually plugged the rendering engine into Technosphere. As you can see on the left-hand side, it's quite crowded in there. There's a lot of stuff going on. And we zoomed into an area here, and what this is a feeding frenzy of lots of carnivores attacking a herbivore here and eating it. Now, some poor person's going to get an email at home saying that your herbivore, Fluffy Wuffy, was completely destroyed by a pack of crazed carnivores. And these were some of the first animations looking inside. Oh, they were. So we pointed the camera at this guy for about 2 days, and this is what came out. He didn't move, but everybody else did. So really, we were very interested in how we could portray this experience to the user. Now, obviously, we thought, wow, why can't we do real-time 3D on the web? And it's quite simple why we couldn't do real-time 3D on the web, because if we had to make a connection from the client to the server and service maybe 100 or 200 connections and get all the positional data down to the client, do the rendering, there's not enough bandwidth, there's not enough server bandwidth, and really sort of resources available for us to do that. We spent a long time thinking about ways in which we could do that, but we were kind of surprised because Technosphere started to take off just by the email functions alone, and we started to sort of move away from real-time 3D. So here's a quick summary of the actual parameters, or some of the parameters in the creature. There's over 1,000 of them in total that control how the creature moves, and that forms it's what we call a digital DNA, a unique description of that creature. These are some of the phases that the creature goes through. Obviously, the creature, if it's the offspring of two other creatures, starts life as a fetus. It does grow inside one of the parents, at which point, when it reaches a certain size, it is born, becomes a child. And the children tend to hang around the parents. They're not too brainy, they can't get up to much good, so they sort of hang around the parents until they become adults, and they're fed by the adults as well. And adulthood is really the interesting part. That's where they get to chase after other creatures and mate and have offspring of their own and really investigate the terrain. About 80% of the way through their maximum lifespan, they will become an ancient, and their features and functionality start to drop off at that point. They become slower, they can't procreate, and eventually, if they're lucky enough to reach old age, they will become a carcass and die and rot, and the energy that's contained in their body will get fed back into the ecosystem. And there's emails that go out at these key points in the creature's life. At any particular time, creatures can be doing any of these 8 or so main activities. They can be foraging, which is looking for food. The herbivores have to roam through the terrain and locate digital grass, which is not everywhere in the terrain, it's only in certain places. And that grass is grown cycle by cycle by a virtual sun, so there's a certain amount of energy pouring into the system. The creatures sleep. That's usually when they're happy, when they've eaten, perhaps they've mated, perhaps they've achieved all the things they want to do. If not, they will be running around trying to find suitable partners to have offspring with. Or they could be fighting, defending themselves against carnivores, or fighting off other forms of predators. They can also be playing, moving, evading, i.e. running away from predators, or simply just sitting there and rotting, which they do quite a lot of the time, actually. And within each of those major activities, there's a series of actions that they can be doing within those. So they can be, in the case of being pursued by a predator, the herbivore could flee, it could defend itself, it could turn and attack the other creature. And the points at which the decisions are made by the creatures varies from creature to creature. There's a series of parameters that control these jumps between states and conditions. And the key thing about technosphere is that the creature can look at its own internal state, it can look at its own health and its own condition, but it can look outside itself to the condition of others around and the condition of the environment and try to come to some decision about what is the most suitable thing to do for itself. So in order to reproduce, a creature has to find a suitable mate, and it has to pursue it and catch it and say, hey, look, want a mate. And then there may be a chance of conception. Creatures don't conceive on every mate attempt. There's a percentage of conceptions that do vary down through evolution. And the interesting thing about this is that the initiator of the mating process gets to carry the child, which some people feel is quite poetic. And pregnancy only lasts 5 days or so in technosphere, so it's not too arduous on the creatures. Now, the children inherit the characteristics from the parents. They inherit the body parts. They might inherit the body from one parent, the wheels from another, and a mouth from the other. And then some of the parameters are spliced and blended and mutated. And they get the mother's email address, which means if your creature has a child, then that child will start emailing you too, and you start to build up a picture of this sort of family that starts to form out there in technosphere.
Question. When you're originally creating the creatures, do you decide whether they're male or female? Because I remember seeing a choice there.
Yeah, that's a good question. There's no gender in technosphere. The initiator of the mating process is the creature that actually gives birth to the creature. And there's some precedents for that in the real world. I mean, the kind of sex that we have, with male and female, isn't the only type of sex in the world. There's 5 or 6 different types of sex and procreating that are essentially genderless.
So the initiator is the mother.
You can think of the initiator as the mother. It's the one that actually grows the child. But it is possible for the non-initiator to actually have a child itself with another creature. So basically every creature in technosphere could give birth.
Every creature could be a mother.
Yeah. And as I mentioned earlier, what we're trying to do is simulate a whole ecosystem here. And that's slightly different from majority of the A life. And we're using an energy system. As I mentioned, we have calories pouring into the grass on the savanna. We have herbivores that are feeding off of that grass. Now, typically only 10% of the energy in sort of glucose-based plants gets converted into usable energy by a herbivore. And similarly, only 10% of the energy in protein or flesh gets consumed and converted to energy in transition from a herbivore to a carnivore. And so really only 1% of the energy in the real world and in technosphere reaches its way to the carnivorous part of the food chain. And this is a self-leveling feature of the population. It's not possible to sustain huge numbers of carnivores running around the world, attacking everybody, because there isn't enough energy in the food chain to sustain them, which is why big, fierce, rare animals are rare indeed. And this helps to balance the ratio of population in Technosphere. The only problem that we have is that when people use Technosphere, quite a lot of people prefer to make carnivores. And so there's a 10-to-1 number of carnivores that go in there. So they might destroy all of the herbivores in a certain area, but in doing so they'll kill themselves because they deplete their food resource and die over a period of time. So after a while, it comes back into balance. And this is one of the areas that I was particularly interested in, was how you maintain balances in populations. We had some discussions at Digital Biota 2 with some of the key A-Life researchers who were struggling with the same problem of how to balance populations, and it seemed that using energy to do that hadn't crossed their mind, but it seems to work. I don't want to push it too far, but maybe onto something. I think we're also very interested in sort of theories of what I call, or J.J. Gibson, the psychologist, calls direct perception. That is that he believes that creatures have an innate ability to understand their environment simply because they grew up in their environment. The reason we have eyes is because they're light. If there was no light, we wouldn't have eyes. And there's some evidence for this. Obviously, the eyeball has originated in evolution at least 40 times. If you read Climbing Mount Improbable by Richard Dawkins. And the eye is actually quite a simple organ to create in evolutionary time, in the evolutionary process, and it doesn't take a long amount of time for the eye to develop, hence it happened at least 40 times. And this is a direct relationship between organisms and their environment, and they're inseparable. And also, the types of organs and functionality that we have afford us value in the environment that we're in. If I'm hungry, I will go and eat, and I will find other creatures, other ways of finding food in order to sort of satiate that desire. So there's a direct relationship between interaction and affordance. It may be possible as a carnivore for me to pass several herbivores, and if I'm not hungry, I won't attack them. They don't really afford me any value at all. And so, according to my own condition, I would find the affordances in the environment very different. And this leads to a type of embodied knowledge. It's quite easy to look at a life form and understand the environment that it came from and understand the processes that have helped to form that life form. And really, one of the things that we find interesting about Technosphere and reading around ideas of sort of evolution is that we are living solutions to the environment. And the key thing about that is that the environment keeps changing and keeps pushing life forms to different plateaus, different points in evolution. So there's a contest to solve the environment. So talking about that, here is Technosphere. It's a 16-kilometer square piece of virtual terrain. It's fractally generated, which basically means it's easy to generate because it's generated by an algorithm. We haven't had to make the terrain using a modeling package. And the creatures live on the plains. They don't go up into the mountains. And the reason for this is that there's some very, very interesting valleys. You can see a valley in the bottom right-hand corner. If I can get my cursor up just here. Oh. Yeah, the valley down in the bottom right-hand corner. One time we found that there was a ring of carnivores forming an arc at the top of that valley. And we couldn't understand why they were just sitting there, standing there. And when we looked deeper into the valley, we found that there was a whole herd of herbivores just living in that valley, no carnivores in there. And every now and then, the herbivores would leave the valley, wriggle their way up, and the carnivores would eat them. And so, from the carnivore's point of view, it was a really great place to be. But there was no decision mechanism going on in the carnivore saying, okay, right, this is a great place to be because lots of herbivores keep appearing. It was more of a statistic in that it was statistically a really good place for carnivores to live. They get fed a lot. There were other mates in that area, and so the population bloomed in this arc across the end of the valley. And that's an emergent system. Through a very, very simple set of rules, you get what we would seem to be intelligent behavior or emergent behavior that if you looked at the code of the individual creatures isn't actually possible using their own deductive powers. So that is kind of thrilling when you see things like that going on. As you can see, the terrain is divided up into 64 by 64 cells, and all of the population, the creatures, are bound to those cells. They can move across cells, and we process those cells on the simulation server, which is connected to the internet. Just to give you a quick view of the terrain here. And one of the ideas that Jane had in the early part of the project was that she wanted the terrain to really exist only when creatures were in that part of the terrain. So it's kind of like you create creatures forming the environment around them as they move through the environment. And this is the way that she wanted to visualize that several years ago now. As you move over the terrain appears from nowhere and was endless and boundless. I think this sort of stems from the days when we were really trying to understand how we were going to visualize Technosphere. We were able to grow hundreds of thousands of fractal trees and populate the environment with these and allow these to be sort of refuges for creatures to find food and meat below the trees. And so all of these are sort of generated algorithmically. There's nothing modeled in this terrain, and this is a particular interest of mine. One of the things that we're also interested in is different types of landscapes. Obviously, we've only just shown you one savanna-like landscape. We're also interested in desert landscapes, ice landscapes, and water landscapes, waterscapes rather. And we have plans to develop different environments and different servers to allow different types of creatures to evolve within those environments, and to actually allow crossover between those environments for creatures to move from one environment to the other. What I wanted to do now is just sort of move on to some of the simple techniques that we've used to create things like landscapes and trees for Technosphere. Because although the web version is mainly a text-based experience, we've constantly been working in the background to develop a real-time version, which is actually what we're showing at Irvine now. And these are some of the sort of techniques that we use. We use very basic stuff. We use sine waves to disturb polygonal meshes. And obviously, you'll be familiar with the use of sine waves. You can position sine waves in a polygonal mesh and start creating these kind of forms. Here, the sine wave originates from a point in the terrain. So we can start to generate simple-looking valleys. And if we flatten off the bottom of the valley, we start to get the kind of places that we generate and use in Technosphere. And what you can do is obviously add more sine waves together of different wavelengths and different heights and start to synthesize more complex shapes. And I think this one's got 4 sine waves in it, which isn't many at all. The good thing about this is they're very easy and efficient to compute on a computer, and you can generate, semi-realistic or fractal-like terrains quite cheaply. But the main useful thing about this is that there's no modeling by hand. They're all generated by algorithms. Similarly with the trees, we just use basic branching models and recursion, which is basically applying a process over and over again at finer and finer details to generate the trees. Here we've just got one binary branch. duplicate that process 3 or 4 times at each branching level, and you start to form, not realistic, but sort of fractal-like branching forms. Add a few polygons on the end with some texture, and you've got something approximating a tree that doesn't take long to generate at all. In fact, this image I generated here was done about 10 years ago when I was doing my PhD in Coventry, and what I used to do was go into the university on Saturdays because it was the only time that I could get access to the mainframe computers. And I think there were 286 processors. There were 10 of them in a parallel array, and I used to get my hands on this thing and generate these huge forests. And I went in on one Saturday to generate the first forest. It was extremely stormy weather, and a huge thundercloud came in, and as I was generating the algorithms, waiting for this first image to come out, there was a huge clap of thunder, and lightning hit the computer center and burnt out all of the computers and the wiring in the computer center. And I think it's probably the first time a digital forest has been set on fire by real lightning. It was an interesting event. And the useful thing about growing things fractally or recursively is you just change a couple of parameters and you can get very, very different branching models. I think one of the things that I did is I worked a lot on trying to create realistic-looking shadows and textures to really complement the branching models. I'm interested in a sort of relationship between generated textures and generated forms. These were generated on a Sun 360 about 12 years ago. 4 megabytes of RAM. It used to take 4 hours. Now you can do them on this little PC in a couple of seconds, which is great. And by just changing the branching patterns, we can go from a sort of more deciduous to a more sort of African desert-looking kind of trees. So one of the things that we want to do with these trees is to allow birds to land in the trees and to start to be another layer of life within Technosphere, separate from the planes, to allow some interaction between them as well, maybe. So we've got their houses ready to go. There's a view over Technosphere. I wanted to talk a little bit about the interaction models that we're using in Technosphere, or what we understand them to be, and I wouldn't hold them up to say they're the greatest or the best. They're certainly not. When we started Technosphere, we knew nothing. We'd never used the web before. We barely understood how it worked, and we had to do everything from scratch, and we made a tremendous amount of mistakes. But obviously there's the interaction of the user with the interface. This is something that we're all familiar with now. I don't really want to go into that in any great detail. You've got the interaction between the creatures and the users, which is basically the feedback mechanism of the emails. Now that's quite interesting because of the kind of timescales that those email events happen. You've got the interaction between the user and the Technosphere team, that is us. Those are the feedback emails that we get, and we get thousands of them. And one of the interesting things about putting anything up on the web is if you put a contact address, email address, people will contact you and they will tell you what they think of your site. And it's really worthwhile listening to the users of the site because they help you develop your site incredibly fast. You don't have the limitations of the sort of standard CD distribution model, which probably takes a year from one release to get feedback, to get another release out. On the web, it happens the moment you put it out there. You can really use this to drive your projects on if you're prepared to listen to your users. And then you've got the interactions between the users themselves. In the early version of Technosphere, we allowed emails to be sent to deceased creatures. So if your creature was killed by another creature, you would get the email of the person who made the creature that killed your creature. So you could email that person and say, "Oh, you, I don't think much of your creature," or "Yeah, thanks very much, I didn't like that creature anyway." And so people started to send messages to each other and start discussing how their creatures were doing. There's sort of 3 types of modes of play that I think that we're familiar with. There's that short-term play, which is somebody, a child, adult, who's got 5 to 15 minutes to play, to do something on the web, to make something, get some kind of experience. And that really correlates with the making of a creature and experimenting with the information functions. There's the mid-term play, which is playing a game from hours through to days. These are your adventure games. This is an area of play that doesn't exist in Technosphere. This is, as I said, fed more by conventional CD-ROM games. And then you've got long-term play, 0 to 3 months and beyond. And this is where you move into the area of sort of virtual environments, collaborative spaces, chat spaces, those sort of adventure spaces. And there's a unique kind of feedback that you use to continue to engage people in those long-term play. Now, Technosphere fits into the first category and the last category, and obviously the key thing is the emails from the creatures. Keep bringing you back to Technosphere to find out about your creatures. And then there's two sort of main modes, background and foreground. The good thing about background is you can make a creature, send it off into the world, and then you can get back to your work. And then as you get an email, that'll foreground it. You might visit the site and then come back again. And there's a sort of a good balance that we've got, I think, between background and foreground play modes. One of the things that we were surprised about was how the community of Technosphere users grew very quickly and became quite large. And as I say, we thought that the project would run for 2 weeks, but at the end of that 2 weeks, there was absolutely no way we could take it offline because of the users. We found that users developed themselves into local teams and competitions. People in administrative departments would start to have competitions with each other. They'd all make creatures, and they'd all put a chart up of how many creatures babies their creatures had, or how many carnivores or herbivores they'd fought and killed. And the first thing that is administrators and people would do when they came to work was check out their Technosphere creatures and then do the day's work, which was kind of amazing, really. And one of the things that we allowed is the freedom for users to build personal sites using assets off the site. They could use the imagery of their creatures, they could embed CGI calls into their own websites. And we found a fascinating array of unofficial Technosphere websites out there. Things like Technosphere graveyards. People have put up graveyards of the creatures that they had and were now dead. Unfortunately, we couldn't get the internet connection working here, but these are just some of the sort of classic unofficial Technosphere websites. And I think that the thing that we learned from this is you can never tell how somebody's going to use your website when you put it up there. You may think that you have a user, target market, target audience, and that is the only way it's going to be used. That's certainly not the case. We found that Technosphere was used quite a lot in education, particularly in Canada, teaching adaptation to school children. And I think if we'd known that Technosphere was going to be used in the educational context, we'd have been a lot tighter about what we were claiming it was going to be. So it's something that you have to be very aware of, is how people do use your site, which again goes back to listening to user feedback. Sorry, I can't show you these, but they are quite fun. If you just search for Technosphere on Alta Vista or whatever, you'll find a whole bunch of these guys. So let's move on to some statistics. We've had 120,000 different users that we could trace using our web tools and admin stuff, which is probably about a third of the number of people that we know have made creatures. We get about 100 to 1,000 creatures made each day, and we've had well over 1 million. It's nearer 2 million creatures that have existed. And the system sends out about 60,000 emails a day, which is quite huge. And it puts about 3 to 4 gigabytes of data over the internet. And I think the other thing that surprised us about Technosphere is that we designed the system really just to work with 20,000 creatures. And as soon as you reach 1 million of anything, the numbers that you're dealing with and the interactions are so astronomical that it's very difficult to keep the site going. And we officially kind of died. The site went down for good last December. And we've just been rewriting a totally new system now, which we released live on Saturday evening, and fingers crossed it's still running. And that system is designed for one purpose only, and that is to maintain the data, not to crash. And we've designed the system so that even if the simulation isn't running, the user can't tell that it's not running. They can still get data, they can still interact. And so we had to rewrite the software from scratch to really cater for the demand that Technosphere has caused. So we constantly ask ourselves, why was Technosphere found to be interesting by people, and why did we get such a large amount of usage? These are not by contemporary terms now. We're talking about terms 2 or 3 years ago. It's quite common now to put a site up and have hundreds of thousands of users. But one of the key things was creation and ownership. If you create a creature and you name it, there seemed to be quite a strong relationship from the user's perspective. There seemed to be a bonding between putting the name in. And that was the key thing. The naming and ownership kept people attached to their creature. There was the long-term contact and the family tree, the sense that you'd created something that had inheritance, had a family. There was a kind of community of family in there that were in some way yours. And there was some sort of belief, and I think this is sort of more common now in children certainly, the idea of partial life, that they know their cats and dogs are definitely alive, but some of their robots and toys and games, they might say, well, they're kind of alive, they're 60% alive, and they're sort of 40% not alive. And so there's this sort of, not mysticism, but there's a preparedness to believe that some of these things are alive in some way. And we quite often got emails from people who were quite distressed because their creature were dying or starving, and saying, please feed my creature, it's dying, I don't want it to die. We say, no, sorry, can't do it, because they're artificial life, and it would sort of break up this sort of evolutionary thing that we're trying to do. And also, as I mentioned earlier, there's this weak narrative, which is some key text messages that allow the user to really form in their own mind an ongoing story or saga about their creature, which again I was kind of amazed at, really. And I think in the early days of Technosphere, because it dealt with sort of key issues of artificial life, genetics, people from the Human Genome Project used it. Obviously we've now got GM food, that whole debate, World Wide Web as an issue itself, and virtual zoos and pets. We kind of accidentally sort of stumbled on a project that hit all of these buttons, and we got a lot of press coverage and a lot of comment and a lot of criticism as well for actually engaging in these issues. We had an email from a professor in Australia who said, how dare you simplify artificial life and trivialize it and make it a game? And we emailed him back and said, well, we think we're doing A Life a favor by making it accessible, and sort of gave him what for, and he came back and he apologized and he said, yes, you're absolutely right, you're doing the right thing. So hopefully we've managed to get some people interested in it. I wanted to sort of move away from the web now, because that's kind of, in some respects, it's old hat, and although we've got a new version out there, what we're doing is developing lots more applications that are going to sit on the data structures that are on the web, much more gamelets. We've got a TV show that's in development. And I just wanted to show you some images from the first installation that we did back in England. It was a 3-machine piece. There was a server on a network and 2 rendering clients. And the PC server ran the simulation of the world, and the 2 rendering clients got positional data, had a real-time rendering engine put in. And we had 2 projections in the gallery space and touch-sensitive screens so that you could build body parts just by pointing and clicking. And the version that you'll see at Irvine, if you go down and see that, is a standalone system, just 1 machine and 1 monitor, so as the client and server is compressed down. We were using 450 megahertz machines 2 years ago on this, and that could just about handle the 2 things. But now, obviously, with the speed increase in PCs, you can compress everything, the A-Life engine, the graphics, all of the data, into a real-time system on 1 machine, which is great. So what we're planning to do now is release a version of the real-time system on CD-ROM, which will connect to the web. This is a picture from the real-time version. Kids love it, so do older people. This museum has about 1 million people a year through it. They opened a new permanent exhibition called Digital Frontiers. Technosphere is one piece in there. In some ways, it's very similar to the approach that Irvine have taken in the New Beale Centre, a mixture of art, digital media art, and games, old games, new games. Seems to be a very sort of popular approach. And that's Technosphere. It's made out of string and glue. I don't know how many millions they spent on this gallery, and there's this little sort of pokey cupboard that's really, really hot and dust everywhere. It gives me horror, that does. I wanted to play just a video now that shows Jane, the other artist working on the project, and it was made by the Open University back in England as part of their cyber arts shorts, and it shows some of the sort of development and the making of the real-time version. Yeah, a little bit.
We started working in Technosphere in 1992. I finished my degree in fine arts a few years before, and I've got this interest in live art and performance. I was also interested in, if you like, the notion of the site-specific, working in, when I did performance, particular geographical locations or architectural buildings. To me, the internet is a very specific type of site. It enables a particular kind of interaction with your audience. So as an artist, you get a tremendous response to your work, kind of feedback that if you're in a gallery, a few people sign a visitor's book. On the internet, we were getting in Technosphere hundreds of emails a day from users with responses. The way that the artificial life engine works is that we've set out a series of rules which govern the way that creatures interact in fractal terrain. Whilst those rules are individually very simple, in fact you get enormous complexity by partly by the fact that we've got thousands of creatures in this environment, and also because all those rules are being initiated or called upon at any one time. One of the first decisions that you have to make when you come into Technosphere is whether you want to design a carnivore or a herbivore. We get a selection of head shapes. We're going to select from the bodies, and maybe I'll choose this pink spiral body. It gets put into the virtual world. It's kind of teleported in and just lands in the fractal landscape. We've got intelligent grass in Technosphere. As herbivores graze it, it reduces in height, and if they overgraze it, you get these brown areas. The herbivores then have to move on, searching for more fertile grazing. They benefit from the ecosystem. They benefit from the fact that we have a virtual day and night. We have a kind of simulated photosynthesis that's going on. Different kinds of behavioural states, so they might be searching for food, they might be playing, sleeping, they may be looking for a mate. So they roam around the fractal terrain searching for a potential partner. If it found one, they would then swap code, size each other up. They'd have to make sure that the other creature was also more than 50% full of food, and it would then suggest cyber sex. It might be turned down, it might be rejected. If they did have a sexual encounter, then one of those creatures would become the parent and would have a cluster of between 1 and 5 cyber babies that it had to look after, and those babies would try and keep up with it as it moved through the virtual terrain. So whilst on the one hand it is a very picturesque environment, in many ways it is not being kind of sculpted in the style of Capability Brown. What's happening in here is slightly wild and out of control.
Okay, I thought I'd throw it over to questions now, if that's okay with you. Yep.
Sorry, we're streaming.
Well, thank you very much. I really enjoyed that. And as I was sitting here, I just was curious if you had any thoughts in the future of giving creatures collaborative behaviors. I know that this right now, the panorama or the world that you've created is, I'm reacting to it being very survival oriented, more like a primeval soup kind of thing. And I was just wondering what the dynamics would be if there were behaviors that were collaborative that were non-survival based. Because right now you've got basically that like a host-parasite interaction going on with, populations rising and falling on a very, that kind of statistical host-parasite interaction. Just curious. We build cities, we do other things, that kind of thing, so.
Yeah, that's a good question. I think several answers I could give to that. First one is really the complexity of doing that. And some of the considerations that you might look at in that are how do creatures communicate their ideas and intentions, and how do they build higher constructions of thought that go beyond survival. As a programming task, yes, it can be done, and I think you can look at sort of Carl Sims's work and see the way in which those creatures evolved to solve certain problems individually. Those things could be extended to include collaborative work. I think that one of the areas that we're starting to look at is that idea of teams and training creatures and forming your own team with other users that has a distinct name, and those creatures will have certain goals that they're trained well at, but you still train the individual, but you act as a group. That's as near as we've taken our ideas. And we are starting to do that in some of the gamelets that we've got designed for next year. It's a good question. There's a higher level of processing going on there that we don't come anywhere near.
Yeah, no, it's very interesting to think about even those kinds of examples of teams, envisioning that I, as a person who create my creature,
Then I would join with someone else in a team and my collective behavior, or would it just be like that's part of one of the attributes of a creature where when it encounters another kind of similarly minded or, weighted, so to speak, numerically weighted creature, then I would go, oh yeah, okay, that's a buddy, I'm going to herd around with them, and then I'd get an email. I'm like, which way are you thinking?
Yeah, well, there are two approaches. One is clearly evolutionary. You let them self-select who they're close to, and that may enhance that group's potential. Or you force evolution using training tools and tools to change the sort of digital DNA of your creature. And you can do both.
I just had a question regarding the offsprings. Are you yourself giving a kind of a person the tag of a child, or what happens to the child? Who emails the child, or how does the child email? A is that, and B, what determines the body parts of an offspring?
Okay, yeah, it's a good question. The child emails the same email address as the mother. So it's the creature that gestated the offspring, the child inherits that email. Okay, that's the simple answer to that. And the second part of the question.
Doesn't get it because then that child may end up having a child, right? It could just, does it always refer back to some original character?
Yeah. But there are email functions in there that you can turn the email off from creatures if you want to.
One person would be having 2 emails then?
Many, yeah.
You guys have to be a little more media conscious. I'm like, You're not alone. There's other people out there. I know on campus watching. Yes.
Yeah.
I know, but just raise your hand. Thank you.
Yeah.
So the thing is that the mother will have 2 emails then of hers as well as the child's, right?
Yeah, it's exponential according to the number of creatures that
Okay.
you get. But you have the choice to turn email off from the offspring. So, if one creature has 5 offspring, it'll start getting, the person who made the mother will get 6 emails, perhaps a day, one from each of those creatures. But a lot of creatures die. They don't make it. So you don't end up getting too many. And if you do get too many, you can turn the email off from any particular creature you wanted.
And what about the body parts?
Body parts. Okay. There's a couple of forms and ways in which you can simulate evolution. One's sort of splicing, where you take a description, 2 descriptions from the parents, and you cut the description at some point along that line and join the 2 bits together. And so if you can imagine that the body is described and the head and the legs throughout that strand of information, that's how we mix the body parts. You choose by splicing.
Mm-hmm. What about the evolution of the creature itself? Like you've defined it with its eye and body and mouth and wheels. Will they, go through a process of evolution too?
Yeah, they do. The actual physical representation that you're seeing on the web, the actual body, doesn't change, but the parameters within it do change, and that can change as wide and as broad as the evolutionary model will take it. And one of the things that we find is that the creatures progressively get faster. The herbivores get faster first because they try and outrun the carnivores, and only the fastest ones get away. So they mate, and their offspring are faster. But then the carnivores start to catch up because only the fastest ones of those survive. So you get these cat and mouse games going on. That's just with speed, but there are other things like sight as well. And the thing that I should say is that there's a cost to all these things. Some people think, well, if I could make the fastest, most heavily armored, most vicious creature, it would be invincible. No, it wouldn't. It would soon die of starvation because each of those features is very energy intensive. And so the creature starts to predate whole areas just to get enough energy to keep itself going, and it actually diminishes its chances of survival. So some of the things that we might think are obvious survival mechanisms actually aren't. Relatively undefended creatures who can get away from things quickly tend to sort of survive.
I was wondering if you used a particular A-Life toolkit, or if you've thought about taking what you've learned from the construction of this system and making a toolkit out of it for other people to construct A-Life worlds.
That's, again, a very good question. I think what I have to say is that the A-Life component to Technosphere, in some ways, is its weakest part. We're not hardcore A-Life programmers. I think it'd be fair to say that we've got the simplest, most usable thing up and running that we could. And we didn't really understand what A-Life was, and however much reading we tried to do around A-Life, we still couldn't get any answers. And we went to a conference, Digital Biota 2, and we met Chris Langton and Tom Ray, Richard Dawkins, all the kind of key people there, and we had a great time talking with them. And we said, well, look, we don't know if Technosphere is A-Life. And they said, well, we don't know if what we're doing is A-Life. So join the club. And so that kind of put my mind at rest. Also, there's, because we're a small number of people working in our spare time on this, to actually put a toolkit together and to create a really solid interface that works every time with all the distributions to work on the different OSs is a huge amount of work. We would love to do something like that, but it would take funding and it would take some really good applications programmers to make something solid. We're more hacker-based. The nearest thing that we've come close to that is discussing not open sourcing, but allowing people to use Technosphere servers, as is. But that's, those discussions haven't gone too far right now. I think we're still learning about building systems that are really reliable when you get hundreds of thousands of users. It's a different order of magnitude to making something that'll run, with a couple of hundred users in a gallery, and which is what we were more used to doing. There's two things I hated when I was at college. That was networks and databases 10 years ago. Now you can't survive if you don't know about networks and databases, and so I wish I'd done more in that area when I was at college.
I was wondering why you decided to visualize, kind of simulate natural landscapes in an environment that doesn't really need to follow that, and certainly the creatures don't. Is there a reason? Did you think this through?
Yeah, the original idea back in '92, or one of the original ideas that went off at a branch and didn't go any further, was that the landscape wouldn't be a 3D landscape, it would be simply a canvas, and that the creatures would be colours. And how they bred and how they interact and move around the terrain would leave patterns and trails and create 2D imagery. That was the original idea. And we took a decision that in order to engage people, we needed something that was more familiar. Real terrain and real life forms. It'd be quite simple to go back to that original idea, but I think we chose accessibility, really. We wanted people to engage. We wanted something familiar that they could understand and get into. But yeah, we did consider other modes of representing.
Yeah, you've kind of mentioned how that the terrain has some effect on how the creatures will interact, like with the carnivores making that arc. But it seems kind of very simple, like kind of terrain things. I was wondering if you had any plans on trying to bring in more effects of because in real life, terrain can make a big difference on how creatures interact and survive, and certain creatures can have advantages in certain types of terrain over other types of creatures. And I wondered if you were thinking along those lines in any way.
Yeah, we had an interesting discussion with researchers at UCL in London. They've got an A-Life master's course there, and they approached us to talk about doing some kind of collaboration. And they want exactly that, because they make physical robots in their labs, which are very expensive, cost about $200 or $300 a robot, and they can buy 5 of them a year. And they do all their A-Life experiments using these robots, different wheels, different sizes, and try and work out what they're doing. What they wanted was a computer version of those robots, which is why they talked to us, simply so they could program in exactly those characteristics, wheels that work well on terrain or legs that work well on certain terrains. And then you start to get different bands of creatures evolving with those kind of specialities. Yeah, we've thought about it, we've talked to people about it, but we don't do that right now.
All right, well, we have to get ready to hit the road to see your show.
Yeah, me too. We've got to get back before the traffic goes crazy.
Thank you very much for coming.
Pleasure. We
appreciate you being good-humored to be diverted to come and visit us. Thank you.
My pleasure. Thank you. Enjoy the show.
More like 12:40 or so, I think. 45.